I want to welcome my students and specifically my tutor assistant, Dr. Ali Dogondaji, for actually conduct of lectures on this course, Mat 301, Abstract Algebra 1. I want to begin this lecture by giving you a brief history of sets. Now, why did I choose set? Because sets are the building blocks of all of the mathematics. If you don't know set, you will not understand anything in mathematics. They are the building block. You understand what I mean by building block. If you want to erect this building, you start by what? Making blocks, isn't it? Now it is these blocks that you put one after the other that will erect these walls. Now sets are like that to mathematics. Without them, there will be no math, any branch. So I think it's good as students of mathematics, it's good you know the history of how this course actually came up. I believe you know that it did not just descend from sky. It started from scratch out where it is now. There are people graduating with degrees, masters, PhDs, becoming professors in mathematics. It not just come like that. It started gradually. Sets, for example, are actually discovered by what we call a very great mathematician. He's called George Cantor. He lived, I think, around 1870, towards the end of the 19th century. He is the one who actually formulated sets. And he came to the idea of these sets when he was trying to solve what he called trigonometric series, leading to infinite solutions. So he invented this idea of what we call infinite sets, and that says that not have a non-number of elements. Is it clear? But George Cantor actually was met with so much opposition from his counterpart in the late 19th century. But thank God he was also supported by mathematicians like Russell, Dedekind. You remember Dedekind? They supported him actually up to the time that Russell actually extended, together with Cantor, of course, this idea of sets into what you call paradox. So the axiomatic set theory, what we call axiomatic set theory. Now, what we mean by paradox is it's either you believe this or you believe that. If you believe this, there will be problem. For example, the Russell paradox, it says that there exists a collection of subsets which are not members of themselves. So you found out that it looks somehow. If they belong to the set, it will meet a contradiction. So the logic comes in, mathematical logic. If they are not, you also have contradiction. So you have to have axioms now. Axioms are a set of rules which mathematicians, especially algebraists, set for establishing certain theorizing in certain aspects so that you can formulate a general formula for deriving certain things, okay? The example of Russell's paradox is that if you have a collection of different varieties of apples, yellow, green, white, you collect them together, you are going to have something which is not an apple. So You collect apples, but you end up with something which is not an apple. So you have a paradox here. How is it possible? Things like that. So they started now trying to use axioms now to solve this, what they call paradox. This thing continues. This one actually is around 1901. The Russell paradox, very early 20th century, 1901. This also continues. The Zaramello Franklin also came in, building on these axiomatic approaches on set theory, to propose what we call Zaramello Franklin axiom of choice. I think somewhere around middle 80s, 19th centuries. Now, what is axiom of choice? I think early 20th century, 1900, the Ramello axiom of choice came into being. The axiom of choice states that if you have a collection of sets, so you have a set made up of something. Let me write something for you so that you can